Hello everyone, welcome to ChamiViews. This is our 38th video of our Golang series. In the previous video, we have discussed about the worker pools, right? If you haven't watched that one, please look into that because these things are very important when we are learning about the Go, right? Okay, today we are going to discuss about the wait groups. To wait for multiple Go routines to finish, we can use wait groups. When I am doing the examples, I will teach you why we use the wait groups, right? In a simple way. Okay. In here, I am writing a separate function. Right in here, function name is worker, and then to demonstrate the expensive task, I am sleeping some time. This function sleep time dot second, 1 second, right? After that, I am printing learn fmt.println worker complete, right? This simple example. Okay, worker completed. Now if I call to this function from the main, we can call like in this way, right? After that, inside the main function, I am print the by, right? What is the output here? This is a simple example. This program sequentially run, right? And then we can get this output, right? Okay, but I want to concurrently run this worker function, right? Then we can use the coroutine, right? Now what is the output? We already have discussed those things, right? We can get only the by, right? In this thing we can't see, right? What is the reason for that one? The reason is that our main thread complete their task, right? When it's completed, this task is not completed, right? Then we can't get the output of this function, right? To avoid that one, right? We can sleep some random time our main function, like 2 seconds, right? But this is not actually a best practice, right? Because we don't know how much time it will take, right? In here, we know it take around 1 second, right? And then in here we are waiting for 2 seconds, but it is not practical thing, right? Because we can't imagine how much time it will take, right? And according to that time we want to sleep, right? It's not a best thing, right? To avoid that one, we can use the wait group, right? How we can do this thing efficiently using the wait group, right? We can create a wait group like in this way, right? Using the sync package, we can create a variable like in this way, var wait group, right? From the sync package, we can get the wait group, right? Like in this way. And then we want to maintain a counter, right? By using this counter, this wait group know how much go routine runs, right? In here it will run only one, right? Then I have incremented by 1 counter, right? Okay, then Then we want to say this wait group to this function have completed, right? How can I say this worker has completed, right? How can I say? Like in this say, I can start the go routine now, right? It's a simple thing now. After completing this work, it calls the defer function, right? Like in this say defer, and then I am say wait group to this worker has completed, right? After doing this worker things, right, it called to the this defer function, and then say, hey, I have completed my work, right? Okay. And then meantime, in the main function, right, I want to wait, right? All the go routines are completing their task, right? What is the output now? Worker completed, and then we go to the bar, right? This is a very simple thing, right? There is no any hard thing to do here. By using this one, simply we can wait, right? We do not want to add random time, right? Efficiently we can use this by using the wait group, right? Assume that we want to wait for multiple workers, right? Then to identify the each and every worker, I can get ID, right? Type is int, and then I am using the printf worker by using the comma. I can add the ID, right? Like in this, okay. In here I say worker 1 completed, worker 2 completed, like in this, right? Okay. Then using the for loop, right? Using the for loop, I can start multiple works, right? I'm creating a variable called I, right? Let's start with 1, right? And then I less than or equal to 5, I plus plus, right? And then each and every loop I want to start a worker, right? Then we want to add counter by 1, right? In here, right? If it is run in the 5 times, then wait group counter will increase to 5, right? Okay. Then I can run this code inside the for loop. Inside the for loop, I can run this one, right? And then first we will remove this ID, and then I will teach you this one, right? Okay, now we can start the workers, 5 workers, right? Each and every go routine complete their task, it will wait and then print the by, right? What is the output now? Worker completed. In here you can say it 5 times, right? I have seen the new line to identify that proper way. What is the output now? All the workers have completed their work. After that, it will print the by statement, right? This is very important, right? If we want to wait for multiple Go routines, we want to increment their counter, right? Like in this way, right? Each and every iteration I have incremented the counter by 1, right? This is very important thing. Okay. And then if I want to print the ID, right? I have removed before because of some reason, right? I will teach you that one now. In here, ID, right? If I pass directly this I, what is the output now? Right? What is the output now? We can get only worker 6 completed, right? Worker 6 completed. How we got each and every time 6? Because of that, right? In here, we are passing the same I value, no? Right? For this worker. And then concurrently these workers running, right? Concurrently these workers running. Each and every this worker wait for 1 second, right? And then when it comes to this line, right? It got this I value, right? Right? This I value. When it is run, this I is 6. That's the reason, right? We are passing directly this I value, right? Because the memory address of I is same for each and every time, no? Right? We can see that one as well. How we can see that one? In here, I am printing FMT. In here, I print FMT dot println. These are pointer related things, right? Memory. Address, right? Memory address. I, right? By using the AND symbol, we can get the memory address, right? Okay. Now what is the output? I will add the new line as well. Okay. In here you can see memory address is same, right? Memory address is same, right? For this function, we have passed the same I value, right? Once this line execute, it got this I value, right? And then print it, right? When this line execute, the I value is 6 and then print it, right? To avoid that one, we can simply use the copy of this I value and pass a new reference, right? How we can allocate a new variable? We can simply create a local variable I, and like in this way, this is a new variable, new I variable, right? Now I am passing this new I. That now each and every time it has a separate address, right? Not a same address, right? This is a very important thing, right? Please keep in those things in proper way. Now you can get worker 1 completed, worker 4 completed, worker 5, worker 2, worker 3, and then we got the by, right? These things are very important when we are learning about the Go related concept, right? Each and every simple thing I like to teach you, right? And hope you got a clear understanding about those things, right? If you have learned new things, please share these things with your friends and subscribe to my channel. Okay, we will meet in the next video. Thank you. Bye.